Alright, today we're going to be talking about adding and subtracting polynomials. We've already done some work with this. This is just a review, a refresher to help you out. One of the rules that we have when adding or subtracting, when you're adding or subtracting polynomials, the terms must have the same base and exponent. Those are two very important things. You can't add things that have different bases and different exponents. So if I looked here at my example I have written down, if I have 2x cubed, my x, the variable, is my base, and the 3, the little number up here, is my exponent. And hopefully you know that by now. But you can only add things that have that same base and that same exponent. The other important fact to know is that you can only add the coefficient. Do not add the exponents. So when you're adding or subtracting, make sure you're only adding these coefficients. And the coefficient for this example was the 2 because it's in front of my base and exponent. Those are two kind of important facts to help you out when you're adding or subtracting. We're going to do some examples and see how this works. Okay? So, my first example I have here. Number 1, you have 2a squared minus 6a plus 3a squared minus 2a. And the first thing I like to do, I look through the whole entire problem and see what looks similar. Okay? If I looked at the first term here, I have a 2a squared. I noticed the base is an a and the exponent was a 2. So I want to look through this entire thing and find other terms that match this a squared. If I look through here, I found a 3a squared, and I know that because I underlined here, and what I underline, I'm going to match up over here. So my underlines matched up because they had the same base and the same exponent. So I'm going to add those two together. This was a positive 3 and a positive 2. That becomes a positive 5. And then if I need to make sure I don't add these exponents here, okay? Just like I just said, don't add this. This does not become a 5a to the 4th. You simply need 5a squared. Because they had that same base and that same exponent, we keep them the same. The other two things that were left, once I underlined and I got rid of those, I have a negative 6. Now that was a minus sign, but because I want to know what kind of 6 this is, I look in front to see what the sign is, and my sign was a minus, so it's a negative 6a. There's no exponent, so I don't have to worry about it. And then I look over here, and I have a negative 2a. That is also the same because they have a base of a, and the exponent is actually 1, but it's not written. It's just imaginary, I guess. So we have negative 6, and we combine that with negative 2. That gives us a negative 8a. So my whole polynomial, my answer, will become 5a squared minus 8a. That is just combining the like terms. Okay? And again, don't add your exponents. You only add the coefficients, the big numbers, in front of your base and exponent. Okay? So that's an example of adding or combining like terms. We're going to do another one with subtracting. Okay? And it gets a little bit more complicated when we're subtracting. When we're subtracting here, if I have 8x to the 4th plus 2x squared minus 7 minus 6x to the 4th plus 3x squared plus 5, again, I want to start by underlining or circling or just recognizing what matches up, what has the same base and what has the same exponent. So if I looked at the first term, I have 8x to the 4th. I look through the entire thing, that if I can combine it with where I'm going to subtract it from, the only thing that matches up with that is this 6x to the 4th. So I know I can subtract those two things together. So 8 minus 6, because I only subtract the coefficients, 8 minus 6 becomes a 2. So I have 2x to the 4th. I don't subtract my exponent. I don't do 4 minus 4. I leave that 4 in my answer. So I have 8 minus 6. That becomes 2x to the 4th. Then I go to the next term. The next term is a 2x squared. I circle it. I want to find something that matches that 2x squared. Over here I have a 3x squared. That has the same base and the same exponent. So I'm going to circle it. Then I'll look at the sign in between. It is a minus sign. I'm subtracting here. So we're going to do 2 minus 3. If I think about that, 2 minus 3 is going to give me a negative answer. So I'm going to have a negative x squared. That imaginary number, I don't have to write 1, but 2 minus 3 is negative 1, so I have a negative 1x squared here. And again, we leave the base and the exponent in the answer. The last part, we have negative 7 left. We box that in here just to recognize that's the last term I have. And then I'm going to subtract it with a positive 5. That was also the last term. So negative 7 minus 5, that becomes a negative 12. So I just tacked that on the end because it was in the last spot in the actual problem. So my final answer was 2x to the fourth minus x squared minus 12. And so that's an example of a subtraction problem. Next, we're going to have an addition problem with a little wrinkle in it. Okay? So we have negative 2m to the fifth minus 3m squared plus 3m plus, so we're adding here, 4m to the fifth plus 2m squared minus 3. Again, start with what you know. I know that I'm going to start with a negative 2m to the fifth. I want to find things that match that same base and that same exponent. So I have negative 2m to the fifth. The thing that matches that over here in this other set of parentheses is a 4m to the fifth. So I know I can combine those together because I'm adding. So negative 2 plus 4 becomes a 2. Again, I don't add my exponent. I simply leave the m in the fifth power, the fifth exponent, on top. So I have 2m to the fifth there. The next thing I see is a negative 3m squared. Okay, that negative, because it was a minus sign, that makes my 3 negative. So I have negative 3, and if I want to find something that matches it, over here I have 2m squared. So those both have an m and a exponent of 2, so I can combine those together. Negative 3 plus positive 2 becomes negative 1. That negative 1 I don't write, but I do have a minus m squared. So if I have a negative 1, I don't have to write the 1 coefficient. I can just leave it as negative m squared. Okay, the next term I look at is a 3m, and I underlined it twice just to make it different because it's not the same as these other terms here. So I have two underlines underneath my 3m. Now if I look in my other set over here, I recognize that there's no other thing that matches up with this 3m. So I can't add it to anything. So you just bring that thing right on down. If it does not have a partner, you just bring it down in your final answer. Okay, the last thing over here I see is a minus 3. I boxed it in, but there's nothing over here to box in as well because there's nothing that matches this whole number. So I just bring that negative 3 on down with its correct sign. Okay, so my final answer is 2m to the fifth minus m squared plus 3m minus 3. That is combining because I was adding. I wasn't subtracting, so I can add the two things together here. And my two parentheses added together gave me this answer. Okay, so we got one more example of subtraction. And it as well is going to have a wrinkle in it that we need to pay close attention to. If I have in my first set of parentheses 6r cubed plus 5r squared minus 4r minus r cubed minus 4r plus 3. Maybe some of you can already see the wrinkle that we're going to have to deal with, but if I look at my first term, I have 6r cubed. 6r cubed matches up with r cubed, and my sign in between is subtraction. The coefficient in front of this r cubed, hopefully you know by now, is a 1. So it's like saying 6 minus 1, that is 5, so I have a 5r cubed starting out. Then I look at the next term, I have 5r squared. Over here, I don't have anything that matches that 5r squared. So I'm simply going to bring it down. Okay? Just like we did in the previous problem. You bring things down that don't have any partners to match up with, I just bring it down. The next term I see, negative 4r. I underlined it twice because it's different than the previous two terms. And if I look over here, I also have a negative 4r. Okay? So I need to make sure I know that this is a negative. I'm subtracting from negative 4r. So if I brought that out, I brought the coefficients out, I have negative 4r minus negative 4. Negative 4 minus negative 4, you're just subtracting it from itself. Anything taken away from itself is going to give you 0. So when I have 0, I don't write anything. I just leave it off. It becomes nothing. It goes away. So my r's disappear. They just become nothing. The last term I see is a 3. So I boxed that 3 in. If I looked over here, nothing matched my 3. So now I have to think of it as nothing minus 3. 0 minus 3, well, that's just simply negative 3. If you type that in your calculator, you would get negative 3. So negative 3 is what I have to tack on the end. Even though there was a plus sign here, I have to remember I'm subtracting that 3. So I have to subtract 3 on the final answer as my final answer here. So it was 5r cubed plus 5r squared minus 3 as a final answer for subtracting. And that is adding. Those are examples of adding and subtracting polynomials. And now you can do the activity that's going to go along with this.